Lesson number 18 here. No, I don't know what you've heard. 9,000. No, there's not 9,000 problems. My goodness. All right, lesson number 18. We got more problems on area and circumference, so we are going to be continuing to use our formulas here. So main thing that we're after here at the beginning is more of our partial shapes and how they're actually a piece of the puzzle here. So we're actually going to skip on down and we're going to jump right to it. Right here, write an algebraic expression that will express the area of a semicircle and the area of a quarter circle. Okay, so semicircle, what does a semicircle look like? Well, it's a circle, all right, except it's only half of it there. I did my best, all right. I don't know, maybe I could do a little better. I'll give it a shot. Yeah, so it's half of a circle, so maybe that's a little bit better there, okay? Versus a quarter of a circle, which is, yeah, a quarter of a circle. So kind of looks like that, and then like that. In other words, it would take 4 of them to make the full circle that we are looking at, whereas in a half circle, it's just half of it there. So we want an algebraic expression that's going to express the area for it there. So a full circle, we know the area is pi times radius squared. But because it's a semicircle, that means it's half the amount. There's 2 ways that you can write it out. To take half of something, you could divide by 2. Yes. So pi times radius squared and divide it by 2. Or the other way you can take half of something is to multiply it by half. So 1/2 pi r squared. So again, it's just the comfort level of what feels better, what's more comfortable to you. It varies from situation to situation. So the big thing here is with a quarter circle, you could take pi r squared, and instead of dividing it by 2, now we're going to divide it up into, yeah, fourths. Because a quarter circle would take 4 pieces to make the full amount. So we could do that. Or the other way is you could take pi r squared, and instead of dividing it by 4, you could multiply it by a fourth. So again, they're both usable formulas. The fractions a lot of times work out a little bit nicer because you're not dealing with the division. Like I said, some situations are better than the others. That's why it's not one size fits all. We do have to look at the individual situation that we are talking about. So let's jump onto it here. All right. Find the area of the following semicircle. All right. So we know for the area, all right, it is pi r squared, but it's a semicircle, so we're going to take half of it. Now, I'm using the 1/2 formula because we're using the 22/7. Again, fractions with fractions. So it's a half times 22/7 times, and then the radius squared. Well, the diameter here is 14, so the radius is, yeah, it is 7, so it is our 7 squared. So a little bit of cleanup here. We're going to do a half times 22/7 times 49. 7 squared is 49. I'm going to put it as 49 over 1 so I can jump right to my cross division. Did you see it? Did you see it? Yeah. So now let's multiply across. 1 times 22 times 7, 154. All right. 2 times 1 times 1 is 2. All right. So 154 halves. If we end up cleaning that up, 76? Is it 70? No, it's not 70. 75 gets me to 150. So what is it there? What is it? Yeah, you can reach your calculator. Ooh, mental math is good. Makes it a little more difficult because of the amount. So it's 77. All right. So 77 centimeters and squared. All right, that's the area we're looking at. What's the area of the quarter circle? All right. Again, it's pi r squared for the area of a circle, but it's a quarter, so I'm going to multiply it times a fourth. All right. So 1/4 times. Again, we are using the 22/7. Again, that's why I'm sticking with the formula, with the the fraction there. And then the radius is 6, so 6 squared then. So this is going to give me 1/4 times 22/7 times, and then 36 over 1. Cross division, yeah, we can skip on over 4 and a 4 once, and the 36 9 times. So now when we multiply across, you get a 7 in the denominator, 1 times 7 times 1. And then 22 times 9, so an 8 to carry the 1, 198. So 198 sevens. If we clean that up, all right, oh my goodness, that is messy. That is messy. Now, on a test, what I would do is I would say, hey, round to the nearest whatever. But here's the other thing too, is what if I told you no rounding? Okay, well, this is where, oh my gosh, I mean, I actually have to do some math here, all right? How many groups of 7 can you take out of 198? Well, if you use your calculator, you're going to see it's 28. but you're going to have some that's left over. So if I do 7 times 28, all right, it goes in 196 times. That means there were 2 pieces. Oh my goodness, look at that. A nice clean answer. All right. So if you're like, wait, what did you just do there? Well, then do the actual division. All right. And then you'll see we have 2 pieces that are left over, and you were trying to put them in groups of 7. So we could do that as well. But again, definitely got to be well aware of how to use our particular fractions. All right, so let's see here. What name do we have here? Marjorie. Oh, that's an interesting way of saying Marjorie there. All right. Is designing a new set of placemats for her dining room. She's got a drawing of the placement on graph paper. The diagram represents the area of the placemat consisting of a rectangle and 2 semicircles at either end. Each grid on the grid measures 4 inches in length. Find the area of the entire placemat. Okay, so this is where sometimes some rearrangement does good. Would you agree that it is a rectangle, all right, plus a semicircle, plus a semicircle? I know I did my best there, all right. But here's the thing is, what happens when you put 2 semicircles together that have the exact same diameter? You get a circle, yeah. So let's see here. Each grid measures 4 inches. All right, so 4, 4, 4, so I know that's 12, and then 4 and 8, so the rectangle is 8 by 12. All right, area of the rectangle, length times width, so we get 96. All right, the area of the circle, okay, area of the circle, pi times radius squared, because it is the full circle. The radius here, okay, yeah, that's 4, so that's 4 squared. All right, now I'm looking at what they ended up telling me here of what they want, plus 16 pi. So my choice, I'm going to go 3.14 because that way I can just reach for the calculator, I can punch it on in. All right, so if I do 96 plus 16 times 3.14, all right, and again, we can type it all in at once there. You're going to get 146 and 24 hundredths, and we are in what units of measurement? Inches. We are inches, so inches squared. All right. She wants to make 6 placemats. How many square inches of fabric will she need? Assume there's no waste. Okay, so in other words, you're going to use the exact amount. So we got 6 of them there, all right? So we'll multiply it times 6, and we get this, 877 and 44 hundredths inches squared. How many square inches is she going to need? So again, assuming no waste, there we go. That's all that we are after, all right? Obviously, in a real situation, we're going to have some left over because of the curved amounts. So we got Marge decides that she wants to sew on a contrasting band of material around the edge of the placements. How much band material will Marjorie need? Okay, so here we go. So she's going to sew it around it there. So in other words, we're going, that's where we're sewing at. So we want you to notice, again, once again, what the piece is. Now, we just can't always say, yay, perimeter of the rectangle. No. I only need this portion of the rectangle. I don't need this portion. Now, what I do notice, though, is this is a half circle. That is a half circle. So yes, if I just simply do the circumference of the circle plus, and then the one line segments, all right, and then plus the bottom line segment, I'm going to have everything. So this is pi times diameter, all right, so that's going to be pi times 8 plus 4, 8, 12, so 12 plus 12, all right, so I add this up, and I have 8 pi. All right, because pi times 8 is 8 pi, and then plus the 24. As we talked about, I'm going to use 3.14, all right, so that way I can get the approximation. Again, test-wise, I'm going to be specific for you guys. We're not going to leave it as open-ended, but again, I think it's good that you guys kind of have this opportunity to kind of hear the different arguments as I go through as what my choices are. And then, remember, it's just perimeter, so it's just going to be inches. All right. So again, good quality problem where you just can't go into autopilot and just say, yay, perimeter plus perimeter, I'm all done. No. Look at the pieces that you got. All right. So example 3, we got circumference. The circumference of a circle is 24 pi centimeters. What is the exact area? Okay, exact area, which means no 3.14, no 22/7. Oh, I know, my goodness here. All right, draw a diagram to assist you in solving the problem. Okay, so the circumference, so this is all the way around is the 24 pi. I know circumference is pi times diameter. So if the circumference is 24 pi, all right, and this is pi times diameter, all right. Well, if I want to solve for the diameter, look, I can divide both sides by pi. Pi. Oh my goodness. Oh my, are you kidding me? Yes, the diameter is 24. So this is the thing about it, is using the exact amounts. Now, even if I use the 3.14 in there, I'm going to end up getting 24 for the diameter. It just happens we want to show you, we use the exact area. Leave it in terms of pi. All right. So I need the area. Area is pi times radius squared. So exact area, I'm going to leave it in terms of pi. If the diameter is 24, that makes the radius. Yeah, that 12 fits nicely. All right. So your area is it 12 pi? Is it 12? Wait a second. That's just, is radius, oh my goodness. Yeah, oh, so it's not 12 pi. All right. It's 144 pi. Yeah. Again, this is why I always have to write the formulas out, because it's going to show me exactly what I'm trying to do that's in there. So what information is needed to solve the problem? Well, if we look back at it there, when we want to solve an area problem, all right, we need the radius. All right, that's the big thing that we've got to be able to do. So if I need the radius, I got to go back and wait. So if I have circumference, though, when I have circumference, I can find the diameter, all right, and then that allows me to figure out the radius. So again, multi-step. What do I need? I need the radius. Well, what can I do here? Well, this gives me the diameter. Oh my goodness, I can change. Yeah. Thinking. All right. So let's see here. Find the area of a circle with a diameter of 42 centimeters. Use 22/7 for your pi. All right, so area of a circle, pi times radius squared. That's what our area is. So use the 22/7. The radius, well, the diameter is 42. The radius is, it's 21. So it is 21 squared. So, hey, I'm busting out the calculator here. I don't know about you. 21 squared. All right, that's 441. So 22/7 times 441 over 1. Again, the cross division might work here, but I've got my calculator, so I'm going to go ahead. I'm just going to punch that in. All right. That gives me 9,702. All right, 7 times 1 is 7. And this is the reason why we like these problems, is because it does make you show your understanding of fractions. It's not that you can just type in the calculator and it's going to do everything for us. We do need to understand squaring. Fractions multiply across. So yeah, we get a nice crisp, clean answer here, centimeters and then squared, because it is area. Again, the big thing here is I needed the radius. So let's see what we got going on here. All right. We got a circle. We got a circumference. All right. The circle is 9 pi. What is the diameter? Well, circumference is pi times diameter. All right. The circumference is what? The circumference is 9 pi. So where it says circumference, guess what you plug in? Yeah, 9 pi. All right. And hopefully you're saying, wait, I've seen you before. How do we get the diameter by itself? Divide both sides by pi. There we go. Nighty night. So 9 is the diameter. All right. So 9 centimeters. What's the radius? Chop it in half. All right. 4.5. All right. I'll buy that for a minute. I don't think we need to really show work to go along with that. I understand. And there's not much to do there. And then your area, pi times radius squared. So pi times and then 4.5. And we do need to square it. I'm wrapping it in parentheses, otherwise I just put the squared symbols there. I don't know if it's just with the half. I don't know what's going on with it. So let's see here. What should we do? We'll square it. So if you want to change it to a decimal, that's fine. All right. So 4.5. So 4.5, and let's square that. And then I'm going to end up multiplying it times the 3.14. All right. 0.14. All right. 63 and 585 thousandths. All right. And again, we're talking about centimeters and squared. All right. So again, when you are looking at this, make sure if they tell you what to use it. Otherwise, you can plug in what you want with it. All right. And so here's the last one. Last one that we're going to do here. If students only know the radius of a, oh, you know what? Hold on. Oh my. Oh, wait, people. We have to get to this one. We have to. All right, so let's see here. We got the area in the rectangle. All right. It looks like a good problem to me. All right, let's get back to it. Find the area of a rectangle between the two quarter circles. All right, if AF is 7, okay, FB is 9, FB is 9, HD is 7, H to D is 7, all right. Use bias 22/7. Each quarter circle in the top left and lower right have the same radius. Okay, which means that if from A to F is 7, how big is it from A to H? 7, yeah. And ooh, wait a second here. What are we looking at? F to B is 9. So what we have to do here is find the area in the rectangle between the two quarter circles. So what they're talking about is everything that's in between here we want to find the area of. So if I take the area of the rectangle, subtract out the 1/4 circle. That's a bad quarter circle, isn't it? Yeah, it's more half circle like. Let's try that again. All right. Subtract out that quarter circle and then subtract out that quarter circle. Then I'm going to find myself in a good situation. So, rectangle. So this is 7 and 9. So the entire distance. And from here, it's 16. How tall is it? That's 7. That's going to be 14. All right. So if I do 16 times 14, I've got the area of that rectangle. So 16 times 14 gives me the 224. All right. 224. Now, the quarter circle. So this quarter circle I can see rather clearly. So I'm going to do 1/4 times pi times radius squared, because again it is the quarter circle. So 1/4, they told me to use 22/7. The radius here is 7, so when you square 7 you do get 49. All right, you could throw the 49 over the 1, a little cross division right away. All right, 22 times 7, 154. 4 times 1 times 1, that's a 4, that's there. Now, what's interesting here is I don't have any information that's over here. So I'm going to go back and read the problem again. Find the area in the rectangle between the two quarter circles. If AF is 7, FB is 9, HD is 7. Used by each quarter circle and top left corners have, oh, there we go. Okay, they have the same radius, which means that, what does this have to be? Yeah, it's got to be 7 as well, which I really don't need to go through and do the work, because what is this quarter circle going to be? Yeah, it's going to be the 154/4 as well. So if I want to clean stuff up, maybe I want to go decimal here. Let me see what that does. 154 divided by 4. Oh, 38.5. That's nice. So the area of the rectangle is 224. I'm going to subtract away the 38 and 5/10. I'm going to subtract away another 38 and 5/10, because again, I've got 2 of them. So we can punch that all into the calculator, do your subtraction, and you end up with 147 in this case feet, and then squared. Oh, what a nice problem that was, people. All right, again, notice I had to go back, I had to reread the question. All right, those were things that we had to watch for. Well, it is. I think there's excitement not over the low price, but the fact that that's such a nice problem. Obviously you're not sharing the same excitement as I am for this particular problem. All right. We're done here, people.